Hello, welcome. So today we'd just like to talk to you about three basic things: open source, open containers. We're going to specifically talk about Docker, and an open cloud architecture, and we'll highlight some of the things that IBM is doing with open source technologies like Docker. Ralph and I both work for IBM, and I'll let Ralph introduce himself.
Okay, so my name's Ralph Bateman. I'm actually from the Hursley Laboratory in the UK. We spent the last couple of years doing a lot of work with various open source technologies, and one of the things we're going to have a chat with you about in the next hour is how we've put Docker into our Bluemix cloud platform. So we'll have a little demo, and we'll probably even show a little game at the end of how you can actually run games inside containers.
All right, and I'm Phil Estes, and I work in IBM's Open Cloud Technologies Lab in the US. And my specific role at this point is that I actually work upstream in the Docker community. I'm a Docker maintainer working on the core Docker engine as well as some other parts of Docker. And we'll talk about that in a few minutes. But first of all, who's heard of this small company, IBM? Surely some of you have heard of them. We might even have a few IBMers here. IBM has been around for over 100 years now, and if you aren't aware of what they're doing, maybe this is what you think of IBM, which is going way back to the era of punch cards. Some of you might actually be younger than the punch card itself. And then typewriters in the 60s and 70s. If you can believe it, IBM had 75% of the typewriter market with the Selectric typewriter. But bringing a little more into the modern era, mainframe computers sort of sound like dinosaurs today, but you might not have heard that IBM just announced new mainframes in the last 6 months running purely on Linux. So mainframes have been a bread and butter of IBM's existence. And actually an interesting note about the one you see here, the IBM Model 3, or System 360 Model 20 was actually developed here in Europe, and I believe was manufactured in France. So this is from 1964 was when this system came out. And if you can believe it, Ralph actually worked on mainframes when he joined IBM.
Yeah, that's very true. So I am an assembler programmer. Things have changed a little bit, but as we go, I started with assembler.
But we don't want to talk just about the history of IBM. Would you believe that IBM is probably one of the instigators of the open source movement? And to understand that, you'd have to go back to actually this era of the System 360. In that era, the end user of a computer was rarely sort of the end user of today, someone who didn't know much about computers but could purchase a computer and use it for basic computing. But in this era, the end user of the computer being purchased from IBM had to be an expert, and many times had to know how to make changes to the operating system. And so in this era, IBM systems were actually shipped with the source code of the operating system. So the expectation was that you got the source code. And so in that era came out a movement called Share that generated conferences and user groups where they actually would share modifications to the operating system. And so if you even read the Wikipedia article on open source, it references the Share era as really the foundation of what we call the open source movement of today. So digging just a little bit deeper, a colleague and I recently wrote this ebook on the history of open source and bringing that into the modern era of what does that look like today and how is it transforming the cloud. This isn't a pitch to go buy the book. This is a free download. You can see the URL there to get a free copy of the book if you'd like to hear more about the history of open source. But the reason I mention it is that coming up to today and the cloud technologies that we have in the modern era in the cloud, things like OpenStack, Docker, and even Cloud Foundry, platform as a service. These are all open source communities that IBM has heavily involved ourselves in. And today we're mostly going to focus on Docker, but we'll look a little bit at IBM's open cloud architecture and what that looks like. Recently, just a few weeks ago actually, one of our vice presidents, Dr. Angel Luis Diaz, mentioned that you can't out-innovate the world, and that's really the message of open source, is that no single company could output the amount of code that's being generated these days, the amount of projects. If you're aware of GitHub and you look at the thousands and thousands of projects being created almost on a daily basis, a few statistics that help put that together. So the Linux Foundation has an umbrella of projects called the collaboration projects. Just these projects alone, it doesn't even include the Linux kernel, has generated 115 million lines of code that in a recent report has been valued at $5 billion. The core Docker engine, so we're going to talk in a few minutes about Docker itself. That project has over 25,900 stars as of a few days ago, almost 7,000 forks, with more than 1,000 people who have contributed code to the Docker project. And then looking at OpenStack, the OpenStack Foundation itself has 28,000 worldwide individual members. More than 100 companies are actual sponsors of the OpenStack Foundation, and those companies employ, again, many hundreds and even thousands of contributors, including IBM. And so really the message is that we have gotten deeply involved in open source software at IBM, both in our initial contribution to Linux over a decade ago, and now with OpenStack, Cloud Foundry, and Docker. And we believe that's really transforming the cloud as we know it. So shifting gears from just a pure discussion of open source, we'd like to take a few minutes to talk about Docker itself, which is both an open source project with a community, as well as the company Docker. In fact, a couple of them are speaking across the hall as we speak. First of all, anyone here played around with Docker, used Docker, tried it out? Okay, we have a percentage, maybe a third. So I won't belabor this, but I think it'd be helpful to get a picture of what Docker is. First of all, many times it is compared with virtualization technologies based around hypervisors. And sometimes that's a hard comparison to make because of the differences of not having really that system image and the boot sequence. So the way I like to think about Docker is that you have a set of processes that have a shared Linux kernel, and the Docker engine really is the arbiter of starting and stopping these processes. There's a REST API, there's the client commands that many people, if you've tried Docker, you've probably tried Docker run Redis or Docker run Nginx. And so these commands interact with the Docker engine, which start processes on your system. Now the important piece is that the isolation that you get with Docker really relies on a set of core Linux kernel technologies that have been around long before Docker existed, such as C groups, namespaces, the Linux capabilities, the Linux security model restrictions like AppArmor or SE Linux. And so these things provide what feels like a virtualization-like environment where in actuality these are just processes that have been isolated using these technologies. And so beyond just that core engine, there is the ability to interact with a hub, either private or public, where these images can be stored. And so now that's generated a whole ecosystem of other projects that I've listed here. Things to compose multiple containers together, swarm, machine. In just recent weeks, advanced networking options have been announced. There's now integrations with other orchestration engines, Kubernetes, Mesos. But the core focus of Docker is to be able, this promise to build, ship, and run distributed applications via this common toolbox. And so maybe just to take an extra minute of your time, especially for those who haven't used Docker or haven't fully gotten the basic concepts, maybe just a simple practical example. So most Docker images start with a Docker file where you can specify an image that you're inheriting from. You can specify other metadata like who's maintaining this image. And then you can run commands, you can add files, you can add tarballs, and you can expose ports. And then obviously at some point you want to run some commands so that when your container starts, you'll be able to actually execute something. And so when you build a Docker file, this will actually generate a Docker image that is comprised of a file system. In this case, the Ubuntu layers will be there, whatever libraries I've added, and my program that I've added into this image is now a shippable, transportable component that I can share with others via a registry or use myself on my own laptop or put into a cloud. And so there are a set of commands, obviously, that you can interoperate, and I think Ralph will be able to show these in more detail when we get to the demonstration. But you can build, run, look at what's running, tag your images, and push them to registries. So these are all sort of the core concepts of what it means to build a Docker image, use it, and run it. And so I think what you want to be left with is the understanding that a Docker container contains a file system, which could be a set of independent and shareable layers. Docker uses a copy-on-write file system concept, which we probably don't have time to delve into that, but that means that actually you're sharing, if multiple containers are all based on Ubuntu, each container doesn't have its own copy of the Ubuntu layers. So that's actually a significant file space sharing technology in Docker. A configuration which says what ports am I going to expose, what command will I be running, and then obviously once I have this file system and configuration, I can take this and push to remote repositories, tag it, share it with others, and obviously there's much more to Docker than just that, but hopefully that gives you a basic understanding of what you can do with Docker. In the interest of time, I was going to show a small example, but Ralph's going to do a great job of showing you some various examples. But I think maybe a great way to differentiate virtualization from containerization is that many times when you think of a virtual machine image, it has to have your kernel and kernel modules and all the libraries and the boot sequence. In the case of Docker, I could actually create a container from a single statically linked binary that does one thing. For example, I could build an HTTP server in Go in about 40 lines of code. And I could build that into a static binary and create a Docker file that adds that single file to a container. And now I have a single shippable sample web server that is actually could be as small as 5 megabytes, has no other files, no shells, no configuration files, and that's a great way to test and run and play around with containers in a way that shows a vast cost saving, space saving from a full virtualized image, and Ralph will be able to display that in more detail. So, what is IBM doing with Docker? As I mentioned, I personally am an upstream contributor. We started working with Docker approximately in summer of last year. We had a single contributor, and now we have over 25 IBMers across the world actually working on Docker. We now have 2 core engine maintainers, myself and one other IBMer. And we have not only contributed to the Docker engine, but we worked in Compose and Machine and Swarm and some of these other components that I mentioned a few minutes ago. So you can see our growth over time, roughly over the past year and a few months of our contribution rate to the Docker community. And so we believe strongly in getting involved in open source, not only to use it in our own products, but to benefit the entire community. And so we've been able to do that with our contributions to the Docker community. So finally, bringing back open source, open containers to an open cloud, IBM has created something called Bluemix, which most of the demonstrations Ralph will take us through can use the Bluemix service. But this is an open standards public cloud platform that also is now available in local and on-premise variants. But because it offers both OpenStack and Docker and Cloud Foundry, it allows the developer to choose what environment they'd like to work in, with containers, with platform as a service, or with VMs based on OpenStack, and allow the tooling that we've added around that, around DevOps and third-party APIs and services, to allow developers to build your own apps your own way. And so Ralph specifically works on IBM's Container Cloud, which we have built on Docker itself. He's going to show, obviously, containers running in that environment, showing that we can maintain the full life cycle, that we can both use the standard Docker commands, but also allows us to add features like logging and monitoring. And then if you broaden out to that entire open cloud architecture, we have IBM containers on Docker, we have virtual machines on OpenStack, and we have all the runtime platform as a service capabilities on Cloud Foundry, all built on top of our software, data centers, and bare metal infrastructure. So that gives you a whirlwind tour of what IBM's doing in open source, what we're doing in the Docker community, and how we're translating that into offerings to the developer through our Bluemix platform. So at this point, I would like to have Ralph show us some great demos of what we can do in Bluemix and with containers.
Okay, so thanks, Phil. So Phil asked at the beginning, who's used Docker before? Yeah, okay, good. Anybody use the new features, things like Docker Swarm and things like the new Docker Toolbox and Kitematic and things like that? Yeah, some. Good. So what we're going to do is we're going to do a couple of little demos, and we have a slight technology problem that will just drive me mad, but hopefully you'll be okay, in that it won't duplicate my screen. So everything I do on here you can't see yet, which is a bit of fun. So what we're going to do is, imagine you're a new developer coming into a shop, and you've been told you've got to get useful pretty quickly. Standard show these days. If we, did I go over there? Hey, there we go. Fine, demo time. So if we have a look, and one of the first things that we look at downloading these days, just so that you can use Docker, you can use Docker in the environment, we'll come on to how we use that inside Bluemix, which is our platform as a service. But if you just want to put Docker on your machine and just get going really quickly, this is where you start. So I've actually done some of these downloads already, so we'll take the Devoxx toolbox, we can download it. I've learned that the Wi-Fi here is not quite as fast as anybody would hope it is. I don't know if anybody else is finding that. I was getting about 0.5 of a meg download speed earlier, so I've tethered to my phone to cheat. So once we've downloaded the toolbox, we get something called Kitematic. And Kitematic links in with your GitHub account, and it links through into all the systems that you've got on there. Now, what we're going to do is we're going to take a simple Nginx system, stick it on a machine, just run it in a Docker container. So if you were going to stand up a HTTP browser or a simple Nginx, then you'd download it, you'd install it, you'd do a load of code changes, and it'd take, I don't know, maybe half an hour or something like that to actually do it. So I don't have half an hour, and hopefully it'll be a lot quicker than that. So I'm just going to go and create. I'm going to go off, connect to Docker Hub, hopefully, and then we will use the downloads that have come through in the system. Come on, connect to Docker Hub. Excellent. Even the Wi-Fi is slow. Well, it says it's downloading. All right, we'll leave that downloading over there. Once you've downloaded it, once it's all actually downloaded into Kitematic, then the main system will show No, it won't download it. That's funny. So the main system will show that you're running Kitematic, you're running an Nginx proxy. Now, I'm going to try one more thing. And then I'm going to flip it over to the video and see if that'll work. So imagine we have downloaded the Nginx proxy. Imagine we've actually got everything there. I'm going to flip over into, here's one I prepared earlier just in case the network really didn't work, which is a shame. I even prayed to the devil gods this morning just to see whether or not the demo would actually work nicely. So this is what would have happened if we'd actually successfully done it. So we download from Kitematic, we link into the system, and we do a download of the main system. That comes down, we come through, do the main download, it successfully connects to the internet, unlike our system here, and it goes off and actually sets up the install and does the install of Kitematic in the main system. Once we've got that, then we just click on, as I did, but failed to work it out because our internet isn't working. It does a download of the Nginx proxy, successfully connects to Docker Hub, and does a download, and that, whilst barely readable, shows me that I have an Nginx proxy actually running with a web server. So it's sat on a simple port, but that's actually running quite nicely. Now, once I've got that, I can actually show the various different interfaces on there, and I can log up the quick start from Kitematic, which shows me a nice little Docker command line. So the Docker command line then shows me various different interfaces, which are barely readable on there. Let me see if I can make it a bit bigger. Is that going to go bigger? Is that any better for anybody? Hey, that's better. So this is going through and just setting up where we've logged into our Bluemix cloud environment. So we log into the IBM Container Service, and we show that we've got our Nginx proxy running down here on a local port. Okay? Once we run that through in the demo, then the main environment will come through, and we load up the web browser. Yes, that's fine. Now, once we've got a web browser in there and we've actually shown the main environment, then we can nice and simply do changes to that. So if I wanted to actually do a change and actually download something based on the Nginx proxy, I'm going to do a clone of a local Git project just to show how simple it is. Once I've downloaded that Git project, it's a simple node sat on top. I can do modifications on it. So I've downloaded now my node clock, which is a Git project that's available. Anybody can go and download it. And that will show me periodic symbols through in a time clock. Simple HTML file based here. Once we take the HTML file, we'll do a couple of modifications on it, and we go through. There's a couple of typos in here that I've actually made, so I'm going to put a quote on the end of the middle there because that completes the HTML syntax properly, and then we'll go and change the title at the top so that we actually show it for the demo. Now, as Phil was saying earlier, you can do all of this on your local machine. So nothing I'm doing here needs any other cloud provider. We've got the various capabilities between Bluemix Local, Bluemix Dedicated, and Bluemix Shared, so the Bluemix cloud system. Once I've got it working nicely in my local machine, the first thing I want to do is run it. So the next thing we're going to do is actually do a run of the environment, and we're going to do a build of this, which will just bop us through into command prompt, and we'll do a Docker build, including my environment. So node clock was the Git application. I'm going to Docker build in there, and that'll build us the actual environment using that Docker file that Phil showed earlier. So we've got a Docker file in there for the environment, and that'll do it quite nicely. So let's wait for that to happen. Build the node clock, my new build. And I missed the dot. See, it really was a live demo. So, do the dot, does the download, does all the install, installs all the component parts. Where Phil showed you through that Docker file, for those of you that already know the Docker, apologies, but where Phil showed you through that Docker file, including other bits, doing an apt-get, doing an install, pulling in various other tar files, then it works quite nicely. So, we've downloaded that, we've done the main install, the build's all worked. So the next thing I want to do is actually run that on my local system. Now, if Kitematic was working nicely and it had an internet connection, then I would show you it running live on the system, but unfortunately, I'm going to let you watch the video there. And that now tells me that I'm going to run a node. I'm going to run my node clock new, which has got the couple of edits on there, and I'm going to change it so it runs on port 8080. So port 8080 will be the exposed port in Docker that actually runs, and now I can lob a web browser, lob an environment, and that shows me the sample of the application actually running. Now, it is a very, very simple app. All it does is it's a digital clock running on the periodic table. I heard the chat earlier all about science, so I thought we'd include a little bit for it. That tells me now my container is running nicely. Change that to 8080. And that's now showing me the new container that we put in with the couple of corrections. And at the top, we can see just highlighted for demo. So it shows me that I've got the old one that was running with the previous build and the new that was running with the new build. So that works reasonably well. Now, the next thing to do is to actually run that in the cloud environment. What we want to do there is we've already done a build. We've done a build of the environment. Next thing we need to do, as Phil was talking about, there's a registry involved. So the Bluemix environment that we have, which is our platform as a service, has a multi-tenant registry inside it. Every user has a registry that they are able to use, and it's keyed off a namespace, very similar to the way Docker Hub does it. So you do a build up here, but you specify this time a -t to tell it where the registry is. So I'm going to use a namespace called molepigeon, and I'm going to load that in, run a build, tag it, and push it up through into the system. This is our Bluemix environment, our PaaS environment. Once we've done the main build coming through, showing my registry, I'm going to show you EUGB, which is the new London environment that we've actually done. I thought we would show that rather than the environment we've got over in the US. So I'm going to do this build. I'm going to put molepigeon in. I'm going to put my node clock new. Once I spell it right. And we'll build it from there. That build's nice and quick because we've already done previous builds of that environment with those changes. So you're only changing the one layer that has changed. You don't need to build everything else. From there, we need to do a Docker push. So using the cloud environment, we've already shown that we can use all the same Docker commands to push into our environment as we could using our proprietary commands or the CF commands, the Cloud Foundry commands. So we've got an extension to the plugin in CF, or you can use the native Docker commands. So this pushes through into all the environment, and it shows me where my tag has gone, and I've tagged it as latest, and I've got it sat there on molepigeon. So the next thing to do is to go into my Bluemix environment, my PaaS, to refresh that because we've done a run on it, or we've done the load on it, and that should now show me a container that's actually been running now in the Bluemix environment. If I list the images that are actually loaded in the cloud, which is the CFIC command, I can see that I've got this node clock new created 29 seconds ago. Actually created 24 hours and 29 seconds ago, but it was created when I did this. So next thing to do, we've got our image, we've got our environment. We saw that we didn't have the container running in the cloud, so now we want to run it. So let's do the CFIC run command. We're going to use the other syntax now. We're going to use our plugin that we've put in Cloud Foundry. We're going to do the same thing and run it on port 8080, so that we can run the app up in the cloud. We're going to run that through the environment, and then we should find a container running in our PaaS environment. Now, the thing that we do with all the container service at the moment inside Bluemix is that we allow you to have a public IP. Every trial account, every user, and Phil will show this at the end, you can get a demo into the Bluemix, and there's a couple of free trials going on. You get a public IP into the container, and you get a static route that you can bind, or a static route if you're in Europe, that you can bind into the container so that you can run direct things into it. You don't have to have strange ways of getting in. Now, we've also come out with the support for things like Docker exec, so you don't need the public IP. You can get in there directly using the container ID, but the facilities are there. So if I do a CFIC PS, so same as a Docker PS, I show that I've now got 2 containers running. The second one, don't worry about just at the moment. Hopefully, I'm going to try the devil gods again and see whether or not it works for the second one. That then runs. I then paste in that public IP address with the 8080 port, and we're running. And that is running on a public IP inside our IBM Container Service in Europe. And 12:17, it really was yesterday. That's not bad. 30:17, it was close. So the other things that we do for free for you, which is part of the reason why we're here talking about how we're doing things in cloud foundational services and how IBM is extending this cloud platform, is we give you a lot of capability for free for things like logging, metrics, statistics. So all I've done is I bound my application, I ran it in the cloud. All of this just turns up because it uses stood out. So I've got a logging environment that all of my containers can log through into. I've got a metrics environment that, as you can see, is just starting to come off because I'd only just started running the container. I'll show you, hopefully, I'll show you in a second where we can see more of that interface. But this enables you to look at your own containers and look at multiple of your own containers running inside our cloud environment. Now, as we said, there are offerings on dedicated and there are offerings on local if you want things closer to your data center or you want things dedicated for your customer, but that environment works quite nicely. So, that's the first demo. That's the failed demo. Let's ignore that one. But hopefully that was slightly useful. Let's go and have a look and see whether or not we can play with these demo gods again. So the second demo that I was going to show you is hopefully something a little bit more interesting. Is actually Minecraft. So who's played Minecraft? Who's got kids that play Minecraft? Mine play Minecraft. There we go. So mine spend most of their lives on Minecraft, so I got them to have a little play for me. I've got a 10-year-old and an 8-year-old, and they seem to spend most of their lives on the system at the moment. So what we're going to do here is, if I can minimize that. That visible? Good. So, here's one I prepared earlier. I'm not going to connect to the Docker hub. I don't know what's wrong with that today. But I loaded up yesterday a couple of images for Minecraft. As we look at the Minecraft server, Minecraft, as you know, is a Java-based application. It runs. There's a simple Docker file for it. If we go and have a look at the Docker file for it, cd Minecraft. Docker file. So that is the Docker file for Minecraft. So it's very simple, based on Ubuntu, does an apt-get, pulls actually something off Amazon. I've played with the 1.88 version, which is the latest one that's out. And it sets up a couple of things, accepts the license, then does a start command. Because we want to run it, I could run it locally, but that would be boring. We've already shown that we can run things locally on a machine. So actually running this in the container service would be more interesting. Partly because I'm sure IBM doesn't want me running games in their container service, but also partly because it's a fun thing to do. So we've done a couple of extensions in the start command because containers, when you first instantiate a container, they take a little while, probably about 10 seconds to get networking, to get the public IPs all routed, to get everything actually working in the environment. So we've put a little delay in there of 30 seconds when the container first starts up, just so that it can make sure that the base environment's all there. So that's my Docker file. Once we got the Docker file, exactly as we did before, we would just do a simple Docker build. So run the Docker build, run the push, exactly as we did before. I'm not going to go over all the commands again, partly because I know the image that's up there is actually working. So if I do a CFIC images, then that shows me all the images that we've got, and it shows me the Minecraft container that I created 27 hours ago, something like that. So now the more interesting thing is I did that push and I did the run, and I actually made it so that it would run on a public IP address. So if I do a CFIC PS, same as a Docker PS that we looked at before, but hopefully live, then it shows me that I do have a successful container running on 25565 as the port that it's actually put in the Docker expose. So we saw that in the Docker file, and that's now a running Minecraft server running in a container on a public IP address in Europe. So let's see what happens. You all got it? Okay. Let's wonder what happens. So there's my containers Minecraft server. Excellent. Okay. Demo number 2 works. I'm happy with that. So here is our container running in a Minecraft server. For those of you that like to have a bit of fun and will suddenly realize what my kids like, we've built Docker in the world. So there's your Docker whale. So this is a Minecraft server running. Anybody can log into this. It's a public IP address. If any of you want to come in and have some fun, it's absolutely fine. The latency is really good running on it. So yes, okay, this is a game. Yeah, this is a graphical game. It's heavy on network. It's heavy on actually doing CPU. So you can see all types of business use for this, because if you can do a game in it, then you can do a lot of other things in it. So the changes, as anybody would expect, are showing things quite nicely. Now, what I showed you before, which is the slightly more interesting part, is that we get logs and things for free. So as we get logs for free, I can go back into my Bluemix container over here. So I'm in my Bluemix dashboard. This is the IP address that I'm actually running my Minecraft container in. Fingers crossed. There you go. Live demo does work. Thank you, devil gods. So we can show that over the last little while, nothing's been happening in the system. Yeah, I log in, and all of a sudden, it starts spiking. I'm starting to do things, I'm starting to use the environment, and my container is running nicely on there. So the other things that we can do, as we showed earlier, is you can look at some of the monitoring and some of the logs. Now, I showed in the demo before, well, in the video before, I showed that there was just a couple of little blobs coming out, and you could see a couple of things coming through. But as this has been running for a couple of days, you can see each time I've logged in to try it. So you can see my CPU usage as we spike. You can see it actually growing. It is a container group, but actually the Minecraft server doesn't quite support multi-servers in a cluster yet. That support is coming. We've got the infrastructure ready so that we can spin up multiple clusters on a heat template, because this does run on OpenStack, so that we can spin up more clusters, more Minecraft servers in the cluster based on demand. So when we get there, it'll be nice. So this though shows where our CPU is spiking, it shows our memory utilization going up some slightly, and it shows me as I fly around the world, it shows the network traffic going up, as you would expect. So the other thing you can look at is obviously the logs. Now Minecraft, for any of those of you that have looked at the Minecraft server log, the one message it spits out almost hugely is can't keep up, did the system clock change? It's just a message that comes out on everything on there. And one of my colleagues is in the game at the moment, or has just left the game, so Mole Pigeon has been disconnecting and joining probably about 50 minutes ago. So this is a public server. It's only for demo purposes. We do shut it down at the end of the day, but if anybody wants to have some fun, then please feel free. But please don't blow the whale up. It took someone ages to do that. Okay, so they were the couple of things I wanted to show you on the demo, and actually show you the interface working. I can shrink that, and then I'm going to disconnect that. And go back to there. With that, thank you very much for listening. Does anybody have any questions? Apologies that the first demo didn't work. I'm going to go and have a look and see what's wrong with Docker Hub in a minute, but I'm pleased the second one did.
Yep, thank you. So any questions about any of what we've talked about, either the open source aspects of IBM's involvement in OpenStack, Docker, Cloud Foundry, or the Bluemix platform that Ralph has shown you?
Excellent.
If not, there's one more slide, I guess, that we just put up. IBM does have a booth, booth 30 downstairs. There's actually a very interesting demo going on there. There's a foosball table connected to some analytics and Bluemix, and they can talk to you a lot more about what we're doing there. And if this is interesting to you, obviously Ralph mentioned there are free 30-day trials of Bluemix. 30 days. But as you want to go deeper, there are some offers for the Devoxx community. Again, you can go to the IBM booth and get a lot more detail on that. And we'll be around for a little bit if you'd like to talk about anything else. But I think that's it. Thank you.
Thanks all for listening.